Okay, so let's look at some things about specific types of chemical equations. Single replacement, double replacement, combination or synthesis, decomposition, and combustion. Those are the 5 types you need to know, correct? So this is a double replacement. Double replacement can be the more complicated of the 5 types. And it's actually, you're exchanging not necessarily ions, but you can break each of these down into 2 parts. An A, B, C, D, and then that's going to yield A, D, and C, B. Hydroxide, I'm saying, is a component. Clear? Now, so here are 2 that I did. This one is a salt of a weak acid plus a strong acid yields a salt of a strong acid and then a weak acid. Yes? Now, the weak acid is going to break down to an acid anhydride, non-metal oxide, and water. Clear? So, the weak acid is going to be carbonic acid, HNCO3, correct? So it'll be, and that's, one of them is on your review sheet. So sodium chloride and then carbonic acid. Carbonic acid, again, is a weak acid, and the weak acid will break down to a acid anhydride and water. Now, notice that this is a gas and it's evolved. That up arrow means gas evolved. Clear? Now, this is lead 2 nitrate plus sodium iodide. See how it's aqueous? These are aqueous ions. The reactants have to be ions. It has to be aqueous. Clear? Let me get something really quickly. Remember what we did with the reaction? You can see a lot of water has evaporated, but you clearly can see the precipitate at the bottom. Okay? So here you're producing a solid, an insoluble solid, and that downward arrow means it's a precipitate. Clear? And that's what the lead 2 iodide is. You can see that on the, does that come in? You see that? That's that on the bottom. You remember it was powder, you couldn't see. It looked like it was an orange solution, but it really wasn't. The orange color was actually the precipitate. So, in a double displacement reaction, a rule of thumb, your reactants have to be ions and in aqueous form. Have to be. Clear? The products, you need to either evolve a gas. This is most of the time. You have to either evolve a gas, you have to take something out of the solution. You have to produce something molecular, and that's molecular. Clear? In other words, you have to get it out of the ion state. Ion, 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 ion. But that's molecular, and you're evolving it as a gas, and water is molecular. Or ion, 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 and then insoluble solid. So you have a precipitate. So you're either producing molecules and or a gas is evolved, or you're producing a precipitate. Something has to drive the reaction. Energetically, a lot of these reactions are neutral. Something has to drive them, and we're not talking about entropy yet. I don't even want to tell you what that word means. But what can drive the reaction, production of precipitate or something molecular, gas being evolved is very nice. Most gases, acid anhydrides, are gases. Hydrogen's a gas. It's molecular, H2, molecule. So you're producing something molecular, and it would be nice if you got it out of the solution completely, and that will drive the reaction to completion. Okay, balancing a combustion reaction. What's a combustion reaction? Oxygen, and then carbon dioxide and water. Clear? This is a hydrocarbon, and then oxygen, carbon dioxide, and water. So you need 5 carbons. Let's do it up top first. And then 5 hydrogens. Sorry, 10 hydrogens. So you need 5 more. And then, so carbons are good, hydrogens are good. The oxygens say 10 plus 5 is 15. So that's 7.5, right? Correct? But remember, you need coefficients, whole number coefficients. So now this is the 1, you double everything. 2, 15, 10, 10. 2, 15, 10, 10. That's lowest ratio. Clear? Understood? Yes? Over here, here's a combination reaction as an example. This is a base anhydride plus water yields a base. Just put that up there because there's one on the test. So you got to know the different types. But you'll have that reduced resource on your test. Okay, so don't go memorizing a lot of stuff. So you have these different types of stoichiometric problems to do. And the third video and last one, if I don't have time this period, I'll do it, I don't know, sometime today. I'll do one during block A. And, all right, clear? Easy? End of video 2, review. Clear? Okay, we're off.